How is it that we find ourselves surrounded by such complexity, such elegance?
The genes of you and me, the genes of you and me, we're all made of DNA. We're all made of the same chemical DNA. We're all made of DNA.
Hi, you're watching DNA Today, a multi-award-winning genetics podcast where we explore everything to do with genetics, from CRISPR to rare diseases to new research. We have won the Science and Medicine Podcast Award for many years now. We have hundreds of episodes, and we really hope you enjoy these conversations where we dive into so many genetic concepts. I'm Kira Deneen, a certified genetic counselor, and your host. Well, Dr. Collins, thank you so much for coming on the show. It is a complete honor to be able to talk to you today. I feel like I've been talking with you because I've been reading your book, Road to Wisdom, and finished it. So thank you so much for coming on the show.
Glad to join you, Kira, and to talk about the book and other things that might be relevant to DNA today.
Yeah, certainly. Thank you. And I first saw you speak at Sarah Lawrence's 2019 commencement. So it was right before COVID hit. And that's when I learned that you and Diane Baker are married. And for those that don't know, they're like, Diane Baker, that's a familiar name. You know her because she's a pioneer and leader in the field of genetic counseling and also graduated from Sarah Lawrence. And I mean, talk about a power couple. Like, you guys are amazing in terms of what you have contributed to science, coming from the genetic counseling perspective, because I'm a genetic counselor.
Yeah.
Did you find over the years of just being able to be partners with her, of just learning more about genetic counseling, in that way, it ended up helping our field of genetic counseling, because you were very in on what is current specifically in genetic counseling? Because being the director of the NIH for so many years, I imagine that had to rub off a little bit in terms of just being aware of what genetic counselors needed in our patients.
Absolutely. It's been one of the great blessings of my life to be married to Diane. Just a wonderful example of somebody who is deeply thoughtful, empathetic, smart, capable, just builds relationships very effectively. And hey, I get to be the person who can call her my spouse. We met actually in a clinic at Michigan when I was there and she was there, and we shared patients occasionally. And then ultimately some kind of spark happened. And a few years later, we got married, although she continued to go back and forth to Ann Arbor for the first several years of our marriage. And finally, we decided we would try cohabitation and see if it would work. I'm glad to say it has. So yeah, I've learned to greatly admire both her and the whole field she stands for by the remarkable work that she and many others are doing, and you are doing. In fact, she's right now working with Sarah Lawrence, her alma mater, on the development of a new program that is going to maybe bring genetic counseling and biotechnology and business sense and a few other things all together to try to create even another pathway for training the next generation of leaders.
I thought I saw her name on something. Yeah, that's very exciting. It's like genetic counseling is a relatively small field. So as soon as you kind of know one person, and you kind of end up learning everybody, especially people that are really pioneers in the field, like Diane. You probably don't do a lot of interviews that the first question is about your partner. So I
No,
think,
but I
thought that was
love
a little
this.
different.
We could talk about this the whole time, would be fine.
Right? Let's not talk about your career. Let's talk about Diane's career. But I really wanted to talk about, for those that are watching the video, this is Dr. Collins' brand new book, The Road to Wisdom. And I had the absolute honor of getting an advanced reader's copy. So that was very cool to be able to have. And I got to meet you in person when I went to present at the NIH. Mm-hmm. So just such an amazing experience. And then you're like, yeah, I'll come on DNA Today. And I was like, oh my goodness. So I can also thank Dr. Green for that too, Dr. Eric Green, for that connection. And in terms of reading the book, you dedicate a good portion to discussing your faith and how it's changed over time and impacted you as a scientist. It's, I would say, uncommon for people to discover their faith and have it be so different than how they grew up at the age of 27. So I'm 29 for reference. So, especially from what I learned in the book, you didn't necessarily grow up religious. So how did you find your faith? I mean, how has your religion impacted you as a scientist and benefited you from that way? Because a lot of people would ask the question, well, how has it conflicted? But I want to know how it's been collaborative and a positive influence.
Well, you're right. I didn't grow up in a religious perspective, and ending up becoming a very dedicated Christian at age 27 is something I never would have predicted was going to be part of my life's journey. But in medical school, which I entered as an atheist, I encountered all of these really wrenching issues of people afflicted with terrible diseases, and many of them facing the end of their life, and tried to imagine how I would handle that, and I wasn't at all sure. And yet some of these people seem to have their faith as a really strong anchor in the storm. And I got curious. And to be honest, in an effort to try to strengthen my atheism, because these people were making me uncomfortable, I decided I better understand something more about what is the basis of this and how could a really skeptical, rational person ever accept the idea of believing in God. To my surprise, there was a whole lot of good answers there. Some of them from science, like, well, why is there something instead of nothing? And why is the universe so finely tuned? And I could go on a long list here, which is in a book I wrote 18 years ago called The Language of God. Ultimately, to my surprise, I found that atheism became the least acceptable of the options. And bit by bit, I began to see that God made sense not only as a creator of material things like the universe, but also as the source of something that you could pin the moral law to. Why do we think there's such a thing as good and evil, and why are we drawn to the good part? That's a hard question to answer on a purely materialistic evolutionary basis, but it makes perfect sense on a faith basis. So yes, I did become a Christian. And how does that influence now? By the way, I've never found conflict between what I know as a rigorous scientist and somebody who is a believer in the words of the Bible. You have to be careful in both instances about what kind of question you're asking and how you're interpreting the answer. But beyond that, and there's a whole foundation called BioLogos, if people want to follow up on this.
We'll link to that in the show notes. Yep, you mentioned that in the book. Yeah.
Lots of opportunities there for further conversation. I think for me, it gives me a perspective I wouldn't have if I was purely focused on what you might call scientism, a materialistic view that there's nothing else there. A perspective on things like ethics. Where does ethics come from? Well, it's an effort to try to follow some kind of sense of morality. Well, where does that come from? That's in there. And also an empathy and a desire to care for others. And certainly my Christian faith in its original form, not necessarily the form you see occasionally today, was all about loving your neighbor and healing the sick and all those things that, as a physician scientist, I hope to be able to be part of.
Yeah. And I think you kind of talk about in the book that there's a lot of questions that we can't answer in science, and we continue to try, but there are the biggest questions in life where faith and religion can give us answers, whereas so far in science, we haven't been able to have those answers, and we may never have those answers. So I think in that way that and you say a few times that you haven't since, that age of 27, when you really came into, as you say, being a serious Christian in the book, that you haven't had that conflict. If anything, it's been very compatible. And I think that was a big portion that I got out of the book. And another big part is that I really admire that you highlight your failures in your career, because you can't have such a notable career without having some failures in there. That's just inevitably going to happen. And I think in most people's career, probably everybody, failures is what we learn the most from.
Oh, yeah.
And one of the most crushing failures that at least you've shared in this book is that you had someone working in your lab that was, if I remember right, a PhD, MD student that had falsified some information that ended up in published papers that had to be revoked. At this point in your career, it was probably one of the biggest failures, issues you had to combat. I mean, public relation issues. How did you handle this? And why was it important for you in this book? I'm assuming it's now decades later to say, I want to revisit that and go back to this really big failure.
Yeah, this was almost 30 years ago. And it was the darkest hour in my scientific career, because you trust the people working in your group, that they share the same values that you do about the rigorousness of the data and the importance of complete transparency about what you know and what you don't know. And yet here in my group, this incredibly talented, but apparently impatient MD PhD student just couldn't wait to get the experiments to actually work. And so he kind of decided what the answer should be, and very cleverly created the impression that it had all been done. And neither I nor the postdoc that he worked with every day had a clue what was going on. And yes, it was a dark moment as it became clear that he had fabricated data, not just in one, but as many as 5 different publications that had to be retracted. This was in the New York Times. This was a moment where it was pretty clear that something awful had happened. I had to do whatever I could to try to figure out how to make this not just a learning experience for me, but one that I could share. And so I spent a lot of the next 2 years talking about this in all kinds of scientific and medical meetings, in case anybody else thought it couldn't happen to them. Just walking through in retrospect the things that maybe should have been a clue that I didn't catch up on, and just providing everybody with a bit of an insight into how this could happen. Also, of course, that it's rare, and let nobody try to argue, therefore, that the whole edifice of science is crumbling. It's not. And anything, of course, that gets done wrong, either because of just experimental error or intentional misstatements, is going to get corrected if it really matters, because science is self-correcting. But what a painful way to discover that. I did feel like, yeah, maybe young people I encounter somehow look at my circumstance and say, well, everything went right for you. You got to be the head of the Genome Project and run the NIH. I guess you never really had to struggle against something that didn't go your way. And I'm like, oh, well, let me tell you about that. And so there's a number of those described in the book, including in the very beginning, where I talked about almost leaving science because my first major project in molecular biology was an utter failure.
Yes, it's like you share multiple failures. And I think that's so important, especially for young people in science that are more towards the beginning of their careers, because we're going to face that. Like, you know, you're not big enough until you failed, I think, in terms of how far you are in your career. And I did want to flip it a little bit and obviously talk about your successes. And as many people know, 1989, very famous year, right? Taylor Swift was born. I know Dr. Eric Green will appreciate that reference. But it's also really important because that's the year that your team discovered the CFTR gene that houses mutations that lead to cystic fibrosis. And this was among, I think, one of the first 10 genes discovered, please correct me, in humans. I mean, this must have been such an arduous process because, again, this is so early on. It is what, 34 years ago, 35 years ago. I mean, and not everybody has the same pathogenic variant. Like we look at other conditions like sickle cell. So that must have made it even harder to find that first change and say, okay, this is CFTR. This is it. I mean, what went into all that? How many years? How many hours?
Oh, years and years. Yeah. People listening to this who can't imagine how you ever did science before you had the Genome Project on the internet.
Yeah.
Just think about that. Turn the clock back in 1980s. We have these tiny little islands of information about the genome surrounded by wide seas of ignorance. And really, cystic fibrosis was the first time with no knowledge of what the function of this gene and its protein product might be. We decided to try and go and find it. All the ones up until then that had been successful, like hemophilia, you knew something about the protein product. Here we didn't. So it was a matter of collecting lots of families, carrying out linkage analysis with various probes, which in those days were rather painful, requiring southern blots. To try to see where is this gene on what chromosome, ultimately figuring out it's on the long arm of chromosome 7, but still in a big, wide open territory of uncharted information. So my lab was working on a way to try to cross those territories more rapidly, something called chromosome jumping. And one of the things that happened here, which is one of the more significant lessons for me for the rest of my career, was I had a competitor in Toronto.
Yes, you did.
And he was working as hard as he could, and my lab was working as hard as we could, but we were both really struggling as the years were going by. And eventually we got together at a genetics meeting and said, why are we doing this as a competition? His approach and my approach, they're kind of complementary. Why don't we just do it together? And on that very day, we did, brought our teams together, We started meeting regularly in a rundown Holiday Inn in London, Ontario, which is halfway between Toronto and Ann Arbor. And it worked because the combination, it was not just more numbers of people, it was more synergies of the approach. It was challenging because we didn't know how many different mutations were going to be in this gene, although there was some suspicion that there might be a founder effect here. And sure enough, as we got closer, not to get too into the weeds, but you could start to see there was a haplotype that popped up a lot, which kind of suggested there's a founder chromosome here. And that, of course, turned out to be the one that carried that causative mutation, so-called delta F508, where there's 3 letters, a CTT, that are missing in an exon of this previously undescribed gene. And when we had that, we knew at last that we had found the answer. But oh, what an incredibly daunting challenge it was. This was a major motivation for the Human Genome Project, both the success in saying, hey, you can do this, and also the, oh my gosh, we don't want to have to do it this way ever again. Let's actually chart the territory and speed up the process for any gene, anywhere on any chromosome, because there will already be information there.
And you got so used to, I'm sure, once you discovered this gene of, all right, now we're reading through the CFTR gene over and over, to the point where when you first saw at NHGRI, where Dr. Eric Green is the director there, that you guys created basically, what is it, one in 10,000 representation of the genome? That is literally the wallpaper. Something like that. Yeah. And so there's
about 1,000th of chromosome 7.
1,000. Yeah.
Of just that chromosome.
And he comes and he shows you it. And you step, apparently, this is what he said. So now you can tell your side of the story. Apparently, you step back and you look at the CFTR gene and you say, right here. And you're able to point out that's where delta 508 is. Delta F508, sorry. I was like, yeah, because you've probably read it through so many times.
Some things get burned into your brain.
Yeah. I wasn't surprised when I heard the story. I was like, yeah, that kind of lines up. Yeah. And I think just what you were saying, that this was kind of a preview of your next project that really, I think, was the biggest project in science to date, I would say. I mean, I'm a little biased. I'm in genetics, right? But where you went from having this race against J. Craig Venter of, all right, we're going to get the draft of the human genome first, versus your team of people all throughout the world that you were leading. What do you consider the most critical moment in the Human Genome Project? I mean, obviously it completely changed the game. You finished that first draft in 2003. So it's been 20 years since. But was there a moment where you're like, we're actually going to finish this? Because the director before you, James Watson, said, we're going to get this done by 2005. And then you then stepped into the role when he left. Right. So that was a huge project to be like, oh, Dr. Francis Collins, do you want to just take this over real quick and do a draft of the human genome? So, I mean, was there a moment where you're like, oh, we're actually like, we've got this? Because in the beginning, like, at some point you say, like, is this just a fool's errand? Like, can we even do this at this point?
Yeah, I was really wondering, should I take this job on, or is it doomed?
Right.
We didn't have the technology anywhere near to the point that was going to be necessary to read out 3 billion letters of the DNA code. We had to figure out how to go from 100 base pairs a day to maybe 1,000 a second. That's a big change.
Huge change.
But fortunately, a lot of smart people came on board, inspired by the historic nature of this, dropped everything else they were going to do to work on this project. And it was an amazing team of highly dedicated people, most of whom were not used to being ordered around by anybody. So I had my moments there of trying to be sure everybody was working from the same worksheet. But I guess I would say it was sort of the spring of the year 2000 where I said, we're going to get this done. It is now really cranking out. By the summer, we're going to have 90% of it. And that's the point at which there was an agreement to make an announcement about that sort of jointly between the Celera effort and the public effort. I would say, though, one of the big issues about the Genome Project that doesn't get necessarily the attention that it deserves was the decision about making the data available to everybody, which is something we in the public project had decided to do going back to about 1996, giving the data away every 24 hours so that people could start working with it, trying to find the gene that they're looking for and not have to wait any longer than necessary. because that was public, that kind of became the ethics of genome projects after that, whether it was, beginning to look at human genetic variation, which was another big progress project right after this, which told us that we're all related to each other, which was a pretty profound insight from genome. Or whether it was trying to understand how the genome actually functions and how the regulatory parts, which is most of it, do what they do to turn genes on or off. But all of that from about 1996 on, the ethics of the program and of the whole community has been, if you're doing a big scale project and producing data that lots of people are going to want, give it away. Don't hang on to it. Don't say, oh, I'm going to play with this for a while. Just give it away.
Yeah, we've seen companies change their stance on that over the years too, with genetic testing companies that have maybe been hoarding data, as I would say, and now is like, hey, let's share the data. Yeah. And so I think that's so important. And you think about, if you guys didn't do that, you started sharing it in 96, the draft wasn't completed to be done until 03. All the research that came out of that for those years, that would have all been delayed. So that, from my little understanding, that makes sense. It's like, if you're getting this information and it was a global effort, it wasn't like it was just your lab doing it. You were overseeing this global project. So share the wealth.
Yeah, and if you look and see what was the discovery of rare genetic diseases, finding the cause, the precise mutations, that was sort of starting off with cystic fibrosis and then percolating along for a couple of years. And then as 96 happened and more data became public, that just went straight up. And now we're at 7,000 different diseases for which we know the cause.
It is amazing. I bet you didn't expect at the beginning of your career, when you did somewhat of a pivot and got your MD and kind of went more into genetics and everything, that we would be at the point that we are today. I mean, it's pretty remarkable.
Never would have thought that. My own lab right now working on in vivo gene editing to try to cure a disease called progeria that we're going to try to actually go in and fix that misspelled letter. In that case, just one T that should have been a C. Unimaginable, and yet entirely believable this could happen in the next few years.
And another aspect that I have to ask you about, obviously, you served the longest tenure of the NIH director from 09 to 21, and you're the only one to have served more than one administration. So you went from Obama to Trump to Biden. So, I mean, that in itself is just remarkable of how long, and that they're like, hey, can you hang on? Can you continue being in this role? Was it difficult to switch between a Democrat to a Republican, back to a Democrat? How much does the current sitting president affect decisions made within the NIH, or is it kind of more separate and you're brought in as needed? Because I don't know how this works. I'm in genetics. I'm not in government.
Well, I wasn't either until all of a sudden I was.
Right. Oh, nine. You're like, okay, now I am.
Deep learning curve there. Fortunately, for the most part, medical research has not been a partisan issue. And so in my many years, 12 years serving as the NIH director, our fortunes in terms of medical research support, the budget and so on, were not really so dependent upon who was in the White House. They were more dependent about who was in the Congress. Because keep in mind, when it comes to budgetary decisions, the president proposes a budget, which is almost always declared dead on arrival. And then the Congress decides what they're really going to do. And unless they do something truly outrageous, the president usually signs it. So I spent a lot of my time over those 12 years really building and nurturing relationships with members of the Congress, being there whenever they wanted a briefing about anything. If they wanted to ask me to help them find care for a family member, I was right there to do that. Sort of building the sense of trust that they could actually reach out and expect to get a clear answer to something that was bothering them. And that, I think, was pretty helpful. And in the course of the last 7 years of my 12, NIH increased its budget with bipartisan support, both the Senate and the House, by more than 50%, which was an astounding achievement after having been pretty flat up until then. So I can't complain much at all. It was a great honor to be part of all three of those administrations. Certainly interactions with the White House, well, those do make a difference in terms of who's the guy in the Oval Office.
It's going to change a little bit. Yep.
I had my chance to be in the Oval Office quite a few times, and they were different depending on whose house it was. But again, it was really most important to be sure Congress was getting the information they needed to try to encourage them to see this is like one of the most amazing things the government does. It saves lives, and it actually is one of the best stimuli of the economy. So what's not to love?
Yeah, you hit both points. It's like we're saving lives and stimulating the economy. Like those are two main points politicians are always talking about, right?
You bet. You bet.
And during your time as president, obviously for those thinking about those years, I mean, we began to face the COVID-19 pandemic, and that was really towards the end of of your position. And first, I want to say thank you so much on the behalf of the human race, really, for working 100-hour weeks. I mean, you said it was like such a sleepless year that it was just, I mean, there's not even words, I'm sure, for what you were experiencing. And to be in that position of the director of the NIH while we're facing a pandemic of that stature. Looking back, what are you most proud of in terms of the NIH, the scientific community during this time? Because, as you just mentioned, trust is so important. And that's something that you really focus on in the book, The Road to Wisdom, in terms of developing that trust with the public. And there are things that your team and the government and CDC all did really well. And then as you talk about in the book, there's things that you're like, I wish we handled things a little differently. Yeah. But what are your thoughts looking back on that time? Obviously, we're still in COVID, but things are different than it was at the very beginning when we knew nothing. And it was very scary and just uncharted territory.
Well, I wasn't the only one working 100 hours a week. Almost everybody around me was in that mode in 2020 and a lot of 21 as well. This sense that we were facing the worst pandemic in more than a century, and that science was going to be called upon in ways that had never happened before to try to come up with that response, and particularly to come up with a vaccine in record time, using a new platform of mRNA that had never previously been carried all the way through to FDA approval, but which showed such promise. And it was absolutely astounding to see the way in which people threw themselves into that effort, beginning with our own vaccine research center at NIH, where Barney Graham and Kizzmekia Corbett, within 24 hours of knowing the sequence of SARS-CoV-2, had already designed the vaccine that became the Moderna vaccine.
And I mean, that is just wild. I mean, to go from March 2020 is when we declared it, okay, this is a pandemic, to I personally got the vaccine as a healthcare provider in December. I mean, I was just like, how? This is just remarkable. Like, I don't think people talk about it enough, how fast that was. And how many lives it saved.
Well, the Commonwealth Fund would say more than 3 million lives have been saved in the US alone by the availability of vaccines. And I do think history will look back and say this was the finest hour that science has ever shown, their ability to meet a challenge of this nature on this scale and to get a success with 95% efficacy and a very limited evidence of any safety problems in just that space of 11 months was breathtaking in every way. And yet we didn't succeed necessarily in the trust part. This is the part that breaks my heart, that we were in a position now to be able to save a lot more lives. And yet 50 million Americans by 2021, when the vaccines were freely available and cost you nothing, said, nope, not for me. There was so much misinformation out there. There were people promoting perspectives for their own benefits that were not true. And people were anxious about this and trying to figure out, who do I believe and who do I trust? The saddest statistic of anything that I can imagine in my entire life is this one. The 234,000 people are now in graveyards because misinformation convinced them not to take advantage of the vaccine that could have saved them. 234,000 people. That's Kaiser Family Foundation's numbers, and they're very rigorously done. How could that happen in this most advanced technological country? This is what woke me up, Kira, to the serious circumstance we're in as a society, because all of that was happening also even before COVID, that we were getting more polarized and more hyper partisan. And then it kind of fed into this crisis where we should have been thinking about the virus as the enemy. And yet sometimes we were just thinking about people who didn't agree with us as they must be the enemy. And conspiracies were easy to start and very hard to sort of take off the table once enough people had heard about them. This is not who we are. In this instance is not just an unfortunate sort of aberration in our culture. This was killing people. I felt I had to do something about that. That's what this book is about, feeling this sense that if I have any credibility for a few people out there.
Oh, more than a few.
Try to remind people the truth really matters. it's not okay to say, well, that might be true for you, but it's not true for me. If it's an established fact, I'm sorry, it's true for both of us, no matter how we feel about it. And that's gotten lost a lot in the current contentiousness, and everybody off in their own bubbles, surrounded by other people who agree with them. So there's a lot in the book about truth. There's a lot there about how science is a means to discover truth and is reliable and something that you shouldn't just decide you don't like the answer because it didn't fit some political message. And there's a lot about faith, because I'm worried our faith communities have also gotten caught up in a lot of the misinformation when they were in the best position, oftentimes, to stand up for truth and for loving each other. And a lot of that has gotten lost too. And then there's the whole idea about how do you decide who to trust and what are the factors that we should all be using to try to do that properly and not get taken in by some message which maybe sounds plausible, or maybe it resonates with our own kind of sense of what we think the answer ought to be. But when you look at it more carefully, somebody just made this up. If we're going to turn this around, our very difficult current circumstance where we're more polarized than anybody can remember, it's going to come from each of us. I don't think our politicians are going to solve it.
And you provide so much insight in the book in terms of having conversations with people that have opposite or very different viewpoints from yourself. And I think that's something that I really, as much as I love nerding out about the genetics and all of that, of course, that's something that I really took away from the book. And a lot of my highlights were focused on that. And, that's why, we're going to be doing a book giveaway, some more information at the end about that. And why I also, at the end of the book, I don't think this is a spoiler, that you propose for people to sign a pledge. And I went ahead and did it and made it public. And I really want to urge others to do it, of just taking a personal commitment to reducing animosity, being generous of spirit, sharing objective truths, and more. So we're going to have links in the show notes for all that. But I do want to be conscious of your time, because Dr. Collins, I could talk to you all afternoon. So you've got more important people to talk to, but I cannot recommend the book enough. This was just wonderful. For me, a summer read next to the pool. But The Road to Wisdom is absolutely amazing. I hope that you have a great book tour coming up for people to see you in different places throughout the U.S. And I hear you're going to be on some pretty big talk shows coming up. So I wish you the best of luck with all that.
And thank you, Kieran. I'm glad you brought up the pledge, and I hope people will have a look at that. If we can all kind of begin to take responsibility, at least for ourselves, about being part of the solution, then I think we've got a chance to getting our society back to where it should be. That pledge is posted on the website of an organization called Braver Angels. Anybody listening to this who wants to know what's happening out there to try to cross these bridges that seem to be over yawning gaps between our society, go to Braver Angels, volunteer for them too. They will put you to work in a way that you'll be inspired by. And they've done that for me for the last 2 years. But yeah, sign the pledge, see what you can do. We have a great future. We just have to recover some parts of it that have gotten a little derailed.
Very much so. I think we want to make sure that we're really listening and having truths out there. And especially with the advent of AI, and, there's going to be even more, unfortunately, I think, just, is this real? Is this not? And you provide a lot of good information in terms of helping to figure that out, suss it out. Okay, is this real? What's the source and all of that? So thank you so much, Dr. Collins, for your time and being such a leader, not only in genetics, but in science and medicine. Like your name is down in the history books or whatever we're using in the future instead of textbooks. So Dr. Collins, thank you so much. This has been just such a highlight of my career.
Oh, Kara, thank you for doing what you're doing, running this DNA Today podcast and educating people about all kinds of stuff. I was honored to be your guest today.
Oh, thank you. Thanks for watching DNA Today. To access all of our episodes, head over to dnatoday.com. We also have a lot of bonus content on there that you can enjoy. If you have any questions, comments, suggestions, guest pitches, you name it, send them in to info@dnatoday.com. We'd also really appreciate if you could take a moment to rate and review the podcast on Apple, Spotify, wherever you listen to the show. It really helps more nerds like yourself find the show. Also, if you like giveaways and other ways to connect with us, I recommend following us on social. We're at DNA Today Podcast. We also have a Patreon if you want to be the most level involved in the show. That's also at DNA Today Podcast. Thank you so much for listening and watching. Join us next time to learn and discover new advances in the world of genetics.
They're all made of DNA. We're all made of the same chemical DNA. We're all made